Nothing to it. I also know that, let's see, well, might as well be exhaustive here. I know that 1 minus P1 hat is equal to Q1 hat, and 1 minus P2 hat equals Q2 hat, etc. Now, there's something in here called a pool. We're going to need this. This is called a pooled sample. I'm going to change colors. You know what? Just because this is new and different, and I don't want to be glib about announcing this because we're going to use it in our formula. We're going to use it in our test statistic. Okay. All right. Here we go. So we're going to do. Let's do red. We're going to do pooled sample proportion. Now, again, why we use this, why this is what it is it's above the scope. It's beyond the scope of this class. This is an introduction to statistics. I want you to see it. We're going to do a lot of these by hand. These get a little trickier to do in absence of, to do some real compelling work in absence of computers. But computer software does all of this for you, and it actually spits out. It's got this output that it spits out. But I want you to do these by hand because I want you to see why. And we're not going to do many of them. I mean, we're really only spending a day in this chapter, so it shouldn't be too much torture for you. Think of this as, this is all that we're doing is we're pooling x1 plus x2, and we're dividing it by n1 plus n2. And I'll show you why we need this in just a second. So we know that Q, the pooled sample Q really is just equal to 1 minus this P bar, okay? Think of it almost, I mean, if you look at it, what it is it's the mean of the proportions, right? It's the mean, it's the overall mean proportion. So you take the sum total of all of the, yes, I support candidate A, and I divide it by the total number. In other words, this thing ignores any differences between the populations, okay? Now, here's where it gets fun. All that you need is a z statistic, okay? We're going to do it with z, remember, because we know with binomials, as long as this guy right here is satisfied, we're in good shape, all right? Let's see. So all that z is it's P1 hat minus P2 hat, okay, minus P1 minus P2. Now remember, samples, parameters, and I'll make you guys use these here in just a sec, so no panicking, okay? And this is divided by the square root of P bar Q bar over N1 plus P bar Q bar over N2. Okay? That's all that it is. That's the Z. Okay, this is if we're going to use, this is the guy that we're going to use if we want to do a p-value or a critical value, right? And then for a CI, you can almost look at it and figure out exactly what it is. All right? You can almost look at it so check it out. I know that the difference in P1 minus P2, remember the difference in the proportions, excuse me, all that it's going to be is P1 hat minus P2 hat minus the error, put a little thingy dingy there, and we're going to have P1 hat minus P2 hat plus the error. Now, what's the error? We could actually go through our algebra here, but I'm not going to force you to do that because you would all revolt on me and I'd end up dead, and I don't want that. And this is just z alpha halves, just like we did before, right? So it's based on our alpha, and then I'm going to have square root of, this is going to be P hat 1 Q hat 1 over N1 plus P hat 2 Q hat 2 over N2. Okay? That's if I want to build a confidence interval. That's it. There's no difference. In other words, let's be careful. There are differences just insofar as where this test statistic comes from. It's more complicated. It's a more complicated numerical process. However, if you think about it, it's still going to work out the same way. Once I get this number, I'm either going to look at the p-value, I'm going to look at the critical value. I could build a confidence interval and figure out if my mean ends up, my proportion ends up in this confidence interval. In other words, the techniques that we use to determine whether or not to reject or accept the null hypothesis, we're still just testing around this guy and this guy. These are just the values that we use, all right? So there are your test statistics. These are what you're going to use. Are you going to have to memorize these? Of course not. In fact, we're going to hang them up with the assumptions in the room so that you'll be able to use them. However, you are going to have to be comfortable using them. So let's go through a process, all right? Let me dig a problem out for you guys directly from your textbook. And I'll let you do it, and I'll do it, and we'll compare notes afterwards, and we'll see how we did, okay? All right. Okay, let's put it to the test. You ready? On page 458, there is a problem called Are Seatbelts Effective? It's number, what number is it? It's number 16. Okay, Are seatbelts effective? Is it A or E? It's an E, isn't it? I always screw that up. Effective. Okay, now here's what I'd like you to do. I'm going to push, I'm going to stop, and then I'm going to do the whole problem out down here. But I would like you to try it all on your own. All right, it's number 16. It's not number 15. Number 15 is just building a simple confidence interval. Okay, now I'm going to do it all out, and then I want you to check your work. If you can do this one, you're golden. Okay, when I come back, the problem's going to be completely done here. And I'll walk you through it. It won't take very long at all. Okay, so good luck. Hit pause. Try it out on a piece of paper, and I'll meet you back here in just a sec. All right, here we go. Hopefully you ended up with something like this. Are seatbelts more effective in saving lives? All right, they either, well, I think in the problem it says, I forget what it says. It says, is there a higher rate of fatalities in drivers that don't use seatbelts? Excuse me. So basically, are the population proportions between, let's try this again, for drivers using seatbelts, which would be these guys, versus drivers that aren't using seatbelts, is the proportion of fatalities higher in those not using seatbelts? Well, we know, I mean, this is a pretty obvious problem, but watch how it plays out. They're either equal, or we know that we're really checking to see if those using or not using seatbelts is higher than those using seatbelts. So all I did is I stumbled through, what I really needed was P1 hat and P2 hat, right? So I just stumbled through. Let's see, X1 was 31 out of 2823. Clearly they're independent, right? So I mean, you can't be wearing a seatbelt and not be wearing a seatbelt. I suppose you could gather it from the same accident, like some guy was wearing a seatbelt and some guy wasn't, but that doesn't really matter. All right, so this guy right here ends up being my sample proportion of people that died who weren't wearing seatbelts. This was a sample proportion of people that died who were wearing seatbelts, and then I found my pooled. I suppose I was a little remiss here. I didn't actually come up with Q bar, or my pooled 1 minus P, right, which would just be 0.99, what is that, 56? Okay, I built my little thing. I chose to use a critical value because I had a sneaking suspicion that it was going to be more difficult to find the P value, because I was guessing that our test score was going to be huge, and as it played out, it was. So all that this is P hat 1 minus P hat 2. We know, because of the way in which our null hypothesis is written, I know that P1 minus P2, the true population proportions for both samples, or excuse me, for both populations, is 0. I plugged, I chugged, and this is what I got. And then this is my summary. Since z equals 6.19 falls in the critical region, it's larger than 1.645. By the way, that was my critical value, right, for alpha equals 0.05. Excuse me, which, I mean, if you think about this, if we had to figure out the probability of getting values at least as extreme as z equals 6.19 standard deviations away from the mean, the probability of that's going to be very, very small. It's certainly going to be less than 0.05. We reject the null hypothesis. It appears that fatality rates are significantly higher in drivers not using seatbelts. Ta-da! And we're done. And that's it. That's how it works. That's all we got to do. It gets a little trickier when we build confidence intervals, but we'll do that in class. We'll play with that. It's still this. It's just a variation on the theme. Okay, the theme of, are we going to use critical regions? Are we going to use p-values? Or are we going to use confidence intervals? All right, it's just the same. It's just that the calculation gets a little bit nastier. Okay, we're going to go ahead and move on to the next section, and I'll see you in class tomorrow.